whenever I do a presentation, I generally mostly cover on like applications. So how like 3D printing help for like education sector, especially research and development, and how we can upskill the students with the additive technology, and what are the different type of AM process are available as of now, and our facilities and services. With that, how we are supporting for the different industries. With that, I generally conclude like my presentation. And today, I thank for this opportunity to showcase our portfolio and like our capabilities, how we solve for different industries and education institutions, especially what type of changes is happening in Industrial 4.0 as well as Industrial 5.0. So myself, Arul Regan, I am acting as a application head for 3D Monotech. So I start my journey from PhD College of Technology for the Connect with you all. So my journey also started from the engineering college, where Abdul Kalam started his the first innovation project related to this new technology innovations, the TIFA core. So it is started in around 26 places in India. The one of the TIFA core in PhD College of Technology, it is in Tamil Nadu, it is in Coimbatore. So I part of that project for around 10 years. So there I start learning about this different additive manufacturing process, start from FDM fusion deposition modeling, stereolithography apparatus, and selective laser sintering and vacuum castings and all. So then moving forward with a few industrial exposure, because so like wherever we go, education institution, everyone is entertained, get knowledge about this industrial exposures. So like I also once I completed my master degree, I would like to work with the industries. Why? Because the theoretical knowledge and then the practical how the industrial works is completely differ. It is vary from the industries to industries. Start working with home appliance. It is IFB, well-known company for everyone. Most of the people known in India. So washing machine, especially the front loading washing machine, famous for them. So I'm acting as a 3D printing lab head over there, and then move forward to automotive sectors. For any industries you work, automotive sector is the example for any type of manufacturing industries, because so many developments will happen on automotive industries only. So a lot of automations, robot integrations, new like AI and other stuffs. Generally, they start from automotive because their production line and the need from the market also huge. And every 10 years on, there are a lot of innovations happen like automotive sectors. I got opportunity with work with the commercial vehicle from ZF Wapco, and then past 6 years working with the Monotech System Limited. So what you learn from today's presentations, explore how 3D printing technology revolutioning traditional manufacturing process, because always we compare with the existing process, whatever we buy, whatever we develop, it is always there is some kind of benchmarks already there, because anything we can develop in minimum two ways actually. So like with the additive, how we can break the barriers, and like what is the benefits we'll get out of 3D printing technology, especially the rapid prototyping and customized part design and development. Learn how 3D printing technology accelerate innovative components. If you see, 3D printing is especially used for innovative component development, especially the low wastage, high complex profile with a less lead time, with a reduction of lot of supply chain. We can use these technologies and understand how additive manufacturing helps for lightweight product and high complex geometrical. As I already mentioned, we can break the barriers of traditional manufacturing process with this technology. As of now, I also surprised if you see any industries, automotive, medical industries, or any other industries, we can use this product as a end use parts. So for prototype to end use parts, the evolution is already happens, and it start adapting in the many of the industries, as well as a lot of research and development. It keep on they use this technology for the end use development. I think there is some audio issue. It is not this audio is not audible for you, but I just explained to you. So we do like upskilling program for different industries with our facilities and services. So like what we do, we have additive manufacturing solutions. We integrate with a lot of conventional process industries across like India. And moreover, we have a technical people, and from professor, like we recruit a lot of professors for application side. With that, so these are the missions what you can see here: composite printer, and then other metal 3D printing and reverse engineering. These are the things it is already available with us, and we have a complete portfolio at our Ambattur facilities. At it is a complete facilities is available in Ambattur. So we have a 3D printing machines, application support, and we have a research fellows to help for the different type of research and development. So one of the important factor, this metal 3D printing technology, what you've seen before, these are the technology we already implemented with the different IITs like IIT Madras, IIT Dharwad, and IIT Delhi. They already bought these systems for their research and development. So we closely associate with a lot of engineering colleges for their research and development. If any other industrial problem or problem statement from the government sectors or industries, that also will take it up, and we work with the industries along with a lot of education supports that helps for their research as well as development side. So these are some of the application parts what I explaining to our team members. So for tire industries, for large scale industries, commercial vehicle, or any type of automotive components or part consolidations requirements, those things we generally get those problem statement from the industries, and then we work on it, and we provide as end solutions for any type of industries. So this is all about our upskilling. In upskilling front, what we used to do, we tied up with the education institution or industries. So we present our technologies, and we work with a lot of application case studies. With that, we upskill the trainers who join as a new employee for any industries. And moreover, through them, if any companies or any colleges required support on upskilling for their job seeking, so for that also we used to support. So the role of 3D printer in Industrial 5.0, the main thing is the personalizations. It is widely adapted in different countries, and sustainable manufacturing. And as I already mentioned, waste reduction is another important factor. The carbon footprint we can reduce through this on-demand productions. Right now in Indian market, it's a large volume, low cost volume production. But even though there are some market for on-demand product, and there are customized shoes, footwear industries, and medical implants are based on the demand we are manufacturing, and recyclable materials, and enhance the collaborations with the different industries, improve efficiency. Those things we generally we do on support with the help of Industry 4.0. We help a lot of industries for in this fronts. Generally, this technology is adapted in this area. And then application area, if you see the technology what I explained, rather than the process, this technology is widely used in the healthcare industries as of now. That is a major consumable for getting benefit from additive technology. The first one is a healthcare and personalized implants and drug manufacturing. We also associate with few industries as of now, and Make in India with the paste extrusion printing. We support for a lot of industries for their research using ceramic material, drug research on silicon rubber development and other stuffs. And aerospace industries, lightweight component and then rapid prototype. The other major industries, because volume of the production is less in aerospace, and the demand is already there every year. And automotive industries, as I already mentioned, that is a big benchmark for any type of manufacturing industries. Again, tooling and production jig fixers, lightweight parts can be developed, and customized goods, so mass customization parts. We work with a lot of fast moving goods for regular production applications, on-demand manufacturing, and then pallets, and then production optimization techniques. With that, lot of parts we design and develop. So based on the need, we identify, and then we change metal into polymer, or hybrid manufacturing process we generally do. So the implement of this industrial and academical challenges, what are the implications it is happening in the industries as of now? So there are lack of AM adaptations in general. If you see in industries or education institutions, because of the previously the technologies are very high. Because of that, people are not adapting. But as of now, with the lowest cost, also people can adapt this technology. But this is a big challenges in the academical industries, and because of this technology, how to use, they are struggle with achieve product quality, and then they optimize the production cost also, and the lack of innovations and competitiveness, and the lack of proper investment on these technologies, because they buy technology but they don't know how to use this technology and where to use that. So no quality program and curriculum development, because it is not part of their regular curriculum. And we support for board of studies to like frame the syllabus on AM process, and no utilization of AM. Even the technologies are there, there are not proper utilization and hybrid manufacturing to optimize the cost, and lack of cross industrial exposures, because this kind of faculty development program or industrial visits helps to adapt. But these are some of the challenges. So with that, what is our recommendations or like industries awareness campaigns we generally conduct? With that, we tell how this industry is moving forward, and participate and demonstrate case studies, because with the use case studies only you can understand how this technology will work. And the skill development program we conduct, and then infrastructure setups we used to help, and then training and placements also we take part of that program. So as I mentioned, this additive manufacturing program, in general, the research, the material development is a major research in India. Wherever we visited, rather the technology, people are use this forum or this technology front. People are a lot of the material development they work, and we have a lot of open source machines. And with that, we use this material development material, and then can develop the products or components, and process optimizations designed for AM, and techniques like lattice structures, topology optimization, multi-material printings, and sustainability, tooling applications, hybrid manufacturing, advanced applications. People can get benefits from this additive. And this is a major research is happening. And moreover, college students, how when they learn about this technology, what type of job opportunities they are getting. In general, people placed on design engineers, and application role is other major criteria. So we generally teach, because when you learn about the applications, you know how to solve the problems with the emerging technology. And the process engineering, quality engineers, and sales and marketing is always forefront for any industries, and maintenance, and then medical application specialists and entrepreneurships also we provide support based on their requirements and needs. So there are a lot of departments available, any colleges. So if you see mechanical engineering, people will learn about a lot of engineering subjects, and especially they learn about the design and prototypes and complex geometrical designs, and development of critical thinking, and then hands-on experience, and then other learning programs. So if you see, these are some of the parts using composite material what we develop. And this industrial 4.0 or industrial 5.0, the robotic arms, or process optimization or cost optimization, we use this technology parts for those developments. So the brake lever we develop using composite material with reinforcement, and then throttle body systems also developed through Onyx parts, and wing parts with the lattice structures, or honeycombical structures we develop, and grill part, and then handle. So we develop for automotive industries, and inlet also we developed using composite. technology. That is, we called a CFR process. With that, using a 1.75 mm diameter filament, we melt deposit. We develop a lot of like pneumatic clamps for manufacturing industries, welding fixtures and pistons, molding tools, inspection fixtures, soft jaws. Those things we develop through this. And not only that, this can help to develop composite metal to composite, even direct metal gear parts and vacuum pump inlets and housing seals and other like press tools can be fasteners also can be insert and then develop. So in pattern making, so we can make a mold for mold wooden instead of wooden patterns. We make composite patterns. With that, we can prepare the molds. Through the molds, we can make a castings and lifting tools also like the metal lifting tools can be replaced into composite tools and lightweight composite fixtures are developing through our CFR process. So what advantage we get it is less than 50 percentage, more than 50 percentage weight reduction, lightweight part can be developed, and with that we can improve the efficiency of those lifting tools. And then aerospace industries, drones, other casings parts can be developed, inspection fixtures, CMO fixtures, and custom aircraft dashboards also can be developed through CFR process. So we do support on material development, conductive property material, or other than that some natural fiber, uh, 2 to 3% mixed fiber material also can be developed through our like filament development process. So what advantage we will get it from this? Once you develop the material, we have open source printer. So there are material development is a one stage. The next is find the application. For that, we have to develop the part. So once you identify the material, may be a powder form, it may be a grain form in nature. So for FDM technology, you have to convert into wire form. So for that, filament textures are available. So with that, using PLA, ABS, PP, nylon, PC, TPU material, so carbon, glass filled, and then egg cell and then in powders can be mixed and then develop the parts. So we can coat the part from the normal grains and then through filament development, we develop the parts and then like we can develop a lot of like experimental parts. Through this, you can develop a lot of like Takuchi method or design of experiment you can carry it out. So through this, a lot of research can be carried out. So these are the different type of material. We develop a lot of parts for like impact test, density, and flexural test, impact test, and then tensile specimens. Or these are the things we develop, and we develop materials. If any college professors required some specific material, rather than spending time on the material development, we develop material and we supply to you, and then through this you can uh, focus on the application and so how this technology will work, like if you can see here, this technology can use for like standalone machines and robot fixers and then other stuffs. We can develop this technology in this front, like I was. So the before that I explained about the polymer, and then now just talk about this metal process. It is a standalone machine and robot integration, and then CNC integrations. So the standalone blue laser head, with that the high complex parts can be developed, and full integrated chamber with that 300 by 400 600 size parts can be developed, and with that any type of like dual material can be print, and visual systems, and print can be resumed, and factory calibrations, zero clamping, point clamping also another advantages what we will get it. So 3200 kg per year we can print parts through this technology, more productive than the general one machines. And aerospace brackets, spline shafts, and then other models, molds we can create, nozzle, and then like brackets can be developed, watch vessels also can be developed. So no fiber laser here. It is a blue laser deposition head, and then no calibration is required. Um, and service is also less. New sensors we use to provide the optimized results, and visualization systems, and 1000 watts laser power we use. And it is a easy of use technology. So with that we can make like dual material printing, and it is a combination of inconel and then copper. So through this we can get a lot of benefits of cost saving, and then high complex geometrical parts can be developed through this. And engineering integrations can be like engine integrations with the robots. It helps to make high complex geometrical parts, and 1 minute. We can do a lot of research on like materials, like with the laser power and printing speed. With that, we can develop a lot of parts. So with that, even multi-material printing also possible with this process. And like in metal, like electrical and electronical heat shrink parts can be developed. Engineering applications. If you see this before that, if you see what are the mechanical, electrical and electronical department, PCB covers and other electrical and electronical equipment can be developed through this enclosure parts. And electronical and communication engineering, rapid prototyping, and customize part cost effective learning integrations with IoT, and practical skill development programs can be developed through this. If you see like camera mounting, robot gripper, and end effectors, and apart from that, electronic applications, CFF enclosures with the ESG nature material, and then DLP, using DLP technology, connectors, and high complex profile parts can be developed. And department of design, freeform design, structural design parts can be developed. And department of printing prototypes and other stuffs can be developed. Like lot of grippers and end effector parts can be developed through this. Civil engineering, structural modeling, customize components, hands-on on testing parts, geometrical environmental models, efficient design integrations can be developed through this. So even temporary walls and ergonomical test parts and visualization prototypes and high complex profile parts can be developed through this. And so Department of Applied Chemistry, a lot of research can be carried out, and customized experimental things we can do, and then prototype testing, complex geometrical part, education models, efficient design integrations can be carried out from this technologies. So not only that, and then like a lot of application using FDM and DLP. So any type of complex profiles can be developed, even with a different type of material customized material development. We can do a lot of research on materials. And then in the 3D printing future, if you see like our facilities, there for around 10 years. So in we can manufacturing future with the 3D printing technologies. So in that, like in front, if you see from 1999, from 2000, and right now we are working on 3D, 3D printing also. So with our complete portfolio, we saw a lot of application supports across India, east, west, north, south, anywhere in India. So I just move forward about this all this and little overview about FDM, stereolithography, multi-jet printing, SLS, binder jet technology, and DLP process, metal laser, metal deposition, and other stuff. So, like we associate with the different industries. I just move forward with another slide in that updated OEM companies and other stuff we mentioned. So again, I just share my screen. Industries.
Your screen is not visible.
Yeah, 1 minute. I just share my screen again.
Yes, sir.
Hope my slide is visible now. So if you see now, like our
no, sir, your screen is not visible.
no, sir, not. I think it is loading now.
Yes, yes. Okay, great.
So
Yes, yes, yes.
we
Now it's
start with
visible.
like different alliance. So what I would like to tell you is based on the market demand, we associate with a lot of Indian made printer, the paste extrusion printing from Fab Forge. It is a well-known systems for like education institutions, like especially this technology is generally used for research and development using ceramic, bioceramic. I will show you some of the slides in this systems how it will work, and this paste extrusion printing widely implemented in the education sectors, how it will work, what type of material we can use, and there are a lot of research happening on this paste extrusion printing and using for biomedical applications, silica rubber for engineering applications, ceramic material for material research and development, and engineering, and even clay for civil applications of clay can be printed with the FabForge. Markforge is again a composite printer, CFR process, BICREP for FDM printing for large format printing, W2P for dental applications, Meltio for, as I mentioned, it is a laser metal deposition process, 3DO from Netherlands for filament development, Formlabs from USA for metal, see not metal, polymer, like engineering application and medical application. And then Mimaki, it is a full color model can be printed through this Flash Forge. Again, a Chinese printer for wax 3D printing for jewelry application or investment testing application. Thor and range from 3D scanners. Russia, again, it is from 3D scanning, post-process equipment, and Creality for Chinese FDM printer for low-cost applications, and then Air Max and for powder bed metal 3D printing process. So with that, we generally support for polymer development, metal development, ceramic developments, thermoplastics, wax, the composite and gypsum-based output. And generally, any category, if you see, we provide solutions. Industrial 5.0, it adapt a lot of AI way of process. It may be a VAT polymerizations, powder bed fusions, metal jetting process, material extrusions, sheet laminations, binder jetting technology, direct metal deposition. Anything you can take with this, we can provide solutions with our facilities. So named any technology like stereolithography apparatus, we have in-house facilities. So with that, we develop the parts based on the need of the customer, and then like how it will help, I will show you. If you see this CFR technology, for in terms of research, if you see instead of develop a polymer component, you can develop Onex with like carbon fiber, nylon material. So the combination of Onyx with the carbon fiber, fiberglass, Kevlar, HSHT helps to develop unique outputs from this technology. And then like using a DLP process, high temperature material, biocompactable, elastomeric material. If like any based on the need we can choose this materials and then process the technologies are available within resin form. Only we have to change the resin and then use a right model, and it should be a design for additive manufacturing. So for that also we help to layer by layer print, and then we can develop the parts. And then SLS compact SLS machines we deal with form labs, and using PA11 12 glass fiber material we can develop the parts. So wax material, again, it is a like very niche area. Only less people do research on this wax research, wax converted to metal research. So we have a wax 3D printing, and we serve with that a lot of defense projects. So if anyone is interested, we will help it out. And the visualization prototype for demonstrations for any type of projects, like any industries. If you see to experiment with any new process or component, rather showing to the real product. If you show the scaled down model with the functional color differentiations, with the color jet printing, with the gypsum based powder, that is also possible, can be developed. This is another interesting area. What I would like to explain you today is a BioX4 printer, and then with the paste extrusion 3D printing, as I mentioned, ceramic material, gypsum, silicon, and different type of ceramic material can be used. Even bioceramic hydroepoxide and bio compactability material can be used, and then it can extrude, and then it can be bake or like oven. We can sinter it, and then we can use it. Even food printing, one of the important factor is a cost effective paste extrusion printing, and it come with the forehead. If you see this images left side, and two type of biomaterials can be print, and then tissues can be print with this technology. So the customers, the biotechnology, like hospitals, medical research, food and nutrition research, drug research, people can be used this technology. And then with this, if possible, I will show you in this slide itself some of the images, what type of research we did with that. And these are the some of the area it will be really useful for education institutions. And it is a compact SLS printer. Right now everything is cost effective, and in rather than invest like maybe 10 years before, we have to spend a lot of money to get in the new technology. But right now in India itself, people are start manufacturing the 3D printing machines, and based on the need, we are customized design printers we are developing. So these are the SLS printer, and it is a very small in size, 100 size, with the nylon material we can print. And even if you have a low volume powder, for example, half a kg powder, if you have, with that you want to do research, your like research towards a lot of powder based material, it is affordable. SLS printer can buy and then use it for the real time application in the working environment. So even scanner also we choose not only for only component level scanning, it can scan like human statues, big object, small object, and handy scan. With that, you can convert that into 3D model. So like for the package solutions, we generally recommend if you want to learn about any type of industrial automations or something, and in scaled down version of something, if you want to do 3D scanner is one of the mandatory thing. And with that non-contact 3D scanning, especially we recommend the handheld scanners. And with that compact, easily we can scan and then stitch. With that we can directly print. So recently we work with on use case. One of the defense company, they would like to adapt this technology for training purpose, scan and print. So we give one scanner, and then we give one like a printer. With that, scan, print, and then explain. So with that, lot of advantages. Rather show the real time product. So they explain with the like prototype products, like to the upcoming engineers. So if you see this bike casing covers, the scan and then convert into 3D model that can be print with the 1:1 model also possible as of now, or else if you want to do prototypes or to experiment, explain, or if you want to do some kind of internal test, that is also possible with this 3D models. And then if you want to print and then test, even inspections also widely use this technology. And like as I mentioned, these are the FDM printer, CFR printer, multi-jet printing, color jet printing, and DLP printers are available with our systems. So where we can use this system set. So like especially this technology, when we have a systems experiment learning we can do, and problem solving is in robotic or like drones applications, we instead of rather talk about only theoretical and then like problem solutions or whatever it may be, so we can directly use this for problem solving application. And practically we use application develop and test fix and then test using this real-time environmental. And then engagement, like if you have a physical missions like CNC missions, lathe, and other missions are right now people are start using in the engineering industries. But in 3D printing, not only for mechanical, any type of department can be engaged and get benefit out of this technology. And creativity of things, as you already know about it, in that front we can use. And actual accessibility of getting results within a day, that is possible. So with this, we generally recommend for the training benchmark development. We develop a lot of benchmarks to understand how this technology will work for that industries. So we saw for a lot of automotive industries the conversion of non-ferrous part into the composite parts, and then application support, even like transparent part, hydraulic application, pneumatic applications parts also can be developed. Even batch production applications parts can be developed through these technologies. So that is also possible. So with our soft floor visit or identify. Last time I visited like your engineering college, and I directly met, and through that I connect. I have a lot of connect with the other education institutions. Sometimes we through them we to go and visit industries, identify the correct applications, suggest suitable material and then technology, and then we compare existing process with the 3D printing and provide optimal solutions, and provide a benchmark to and we justify service and require return on investment, and then we provide complete solutions. And thanks everyone. If any specific target need or any specific agenda of this particular program, if you ask me based on our experience, we can provide you more detail. So we generally concentrate new product development. We manufacturing machines and selling across global, and we identify the right machines for right applications. And we like this company constructed based on market demand in two different. Right now we serve for the 3D also, and then integrations with a lot of education institutions as well as industries. That is our core strength. And then we continuously support, not only we are selling product, we have a continuous support for wherever we supply the products. So thanks everyone. I'm looking forward. If you have any questions, I'm looking forward to answer.
Thank you, Mr. J. Arul Regan, for that enlightening session on the principles of Industry 4.0. Your expertise and experience have provided us with a deep understanding of how smart technologies and interconnected systems are transforming industries today. We are grateful for your guidance and the practical knowledge you have shared with us. Thank you.
Yeah, thanks so much. If anything
Hello.
else, if you yeah, if you have any query, please ask.
I have a question. I have a question, sir. My name is Viji Brother from PD Engineering College, Gulbarga, Karnataka.
Okay.
Sir, I
Yeah,
was
please,
talking
sir.
about
Yeah.
you are talking about the applications. In applications, you are telling about on-demand products, consumer products. Can you elaborate on that one?
Sir, on-demand manufacturing is just to give you one example, sir. Recently, when we work with one camera manufacturing company, actually. So what they
Oh,
used to do, generally they make cameras. Right now we generally use mobile, but even though there are some demand for cameras, but the volume of cameras are very less, sir, actually. For India, that per specific camera, they produce only 250 numbers. That is a demand for the customer. So based on the demand, so there is a process they need to follow, supply chain. So once the camera design is completed, they have to develop proof of concept. Then they go for the manufacturing process. For that, die design, die manufacturing, and then go for the industries to make those camera parts. So, for example, camera contained of around 20 plastic components. So instead of rather than go for the supply chain of injection molded design and the manufacturing. So they came to us whether it is possible to develop through 3D printing. So we told that we have a equivalent material like injection molding. Through this, we can develop the parts. Yes,
oh,
and then we suggest the technology and the material. Based on the need, we are manufacturing and supplying to the camera company, and they are saving a lot of lead time, wasting of money and time for get the product for 250 numbers. Through this 3D printing, based on the demand, we are manufacturing and supply continuously. One. The second one is a watch manufacturing, digital watch manufacturing. One of the like hospital research, whoever admitted in ICU, for that patient are little sick. So in that patient, they will fix one digital watch. That watch design is the technology is from that startup company. The casing completely designed and manufacturing by us. So
yeah.
it give detail to doctor when doctor is in home or wherever he is, he can understand his patient present status. So it is again based on the need we design and develop those smart watches. The technology we don't know, but we are not into that also. But that
Okay.
design and develop based on the need, the PCB board and other stuffs they provide. So entire design develop and per year around 300 to 500 watches we are supplying only in Tamil Nadu. So this
Yes.
kind of on-demand manufacturing we are doing.
So thank you, sir. Thank you very much.
Yes, these are the two examples.
Anyone have any queries? Okay, thank you, sir.
Yeah, thanks everyone.
Okay, thank you, sir. Then is completed, then leave now.
So thanks everyone. Thanks for the opportunity. Thank you
Okay,
so
sir.
much.
Okay, thank you.
Thank you.
Thank you all participants.